Time for a video. Good morning, everybody. It is March 10th. Got up this morning, checked my feeds, and looked at the Earth systems map, and things are horrendous. So, start with the weather, only because it's global heating. It's all global heating, folks. It's all because of global heating. It's all because of us. We did this. How did we do this? More on that later. So the central Midwest, upper Midwest, is about to have another record outbreak of tornadoes for March. I did a video, I think it might have even been the last one, a couple of days back, discussing the earlier tornado outbreak in the Midwest that killed, last count I heard, 8 people. It was extreme. People had been talking about it in the weather space. Space I spend some time. I spend some time in the weather space because the weather space is really the climate space. Because the climate is changing. Because the globe is heating. And as the globe heats, it drives climatic changes, and those become visible in the weather. Okay, so that's the chain. Global heating drives the Earth dynamic system, and therefore the climate, therefore the weather. So, like everybody else, I start with weather, and then I go backwards from there. The weather. So, a few days ago, the U.S. Midwest had a tornado outbreak that was unprecedented, record-setting for March. Now, you can have tornadoes in March, that's fine. And everyone will tell you, well, we have tornadoes in March. March in the U.S. is the beginning of the tornado season. That's fine. But these tornadoes killed 8 people. And as I said at the time when I talked about this last, it killed 8 people because they weren't ready for it. And they didn't believe it. The news people were on the ground after the terrible day, and they were talking to people on the streets, and one woman said that she got the emergency messages that said there's a tornado in your neighborhood and you better, duck and cover. And she just didn't believe it. There you go. Just didn't believe it. And the fact that there was 8 people killed suggests that nobody believed it. And why did nobody believe it? Because it's March. And while that is the kickoff to the tornado season in the U.S. for much of that part of the country, they just didn't. It's the beginning. And they didn't believe it. They just didn't believe it. And so it killed them. Now that is a metaphor for what's going to happen to humans on this planet. They're not going to believe it. They're not going to be ready for it. They won't be looking out for it. They won't care. They'll believe something else. They'll believe some fairy tale about what's happening, and it will kill them. That's it. That's the future, folks. It's happening. It's going to continue. It's only going to get worse. It's never going to end. Well, the dying part could end. I mean, all humans could be dead. So I guess on some level it could end, but not in the way that most people would like or think or prefer. So here we are again, a few days later. The weather. It's calling for exactly the same pattern that happened a few days ago that caught all these people by surprise. They just didn't believe it. Straight up admitted to it. I just didn't believe it. It's going to happen again. Now, will they believe it this time? No, they might. I doubt it. I don't think they will. I just think they won't believe it. Because the pattern is it doesn't get bad until May. Real tornadoes show up in May. This is the beginning of the tornado season. Maybe you'll have some warnings, but you can ignore them because it's just the beginning. And the meteorologists, they're just scaremongers, and they just like to get excited about things. And of course, you never want to listen to the climate scientists because it's all a hoax and the whole thing. So they won't believe it. They just won't. And it's happening again today and tomorrow, and they'll get caught in their cars on the freeway, and they'll get caught down at the ball field with the playing softball with the kids and whatever. They'll be out and they'll be about, and then the tornado will come and they'll be like, what's that? Oh, that's a tornado. We can't have tornadoes this time of year because it's March. Well, there you go. They just won't believe it. And why is this happening now? Because of global heating. Because the Earth system is on the move, you see? And people don't understand that. People don't even understand there is an Earth system, that it drives the weather, and that the Earth system, which creates all your weather, including your hurricanes and your tornadoes and your floods and your hail and your everything else, that thing is on the move. It's on the move. And we're in the way. It's moving, and we're not moving with it. We're in the way. We're going to get trampled, clobbered, and wiped out. And this is just the early days. In addition to that little bit of data, basically a continuation of what happened a few days ago, almost a cookie cutter, almost exactly the same thing happening again. Something that was weird happening again. You see, that's the pattern, folks. The pattern is not, oh, one time in my life, one time, in the 60 years I've been alive, one time a weird thing happened. Back to back. Back to back. That's data. That should tell you something. Well, I mean, it tells me something, but I'm weird. I'm a scientist, right? I collect data. I do data analysis. I look at data all the time. I think about data. And then I come on here and I talk about data because I'm weird. Because I'm a sciencey guy, and I'm doing science communication, and I'm communicating to you that these weird things are no longer weird. They're becoming the norm, even though you don't know that's happening. Promote my novel. It was 100 Days. It's about the end of the fossil fuel era. It couldn't happen soon enough to suit me. More relevant today than even months ago, because now we're at war in the oil patch. The Straits of Hormuz have been closed and the oil wells are on fire, and ta-da, here's the cover of the book. So that's what this book is about. And if you're at all curious what I thought was going to happen in the Middle East and how that leads to the collapse of civilization, there you go. Available on Amazon. And link is in the description. Go get yourself a copy. This. So, right. Let's do this. This is a picture of, first of all, this is a climate reanalyzer, which is a website you can visit. You can see it in the URL up there. You can go there and check things out. These are Outlook weather forecast maps. These are models. Okay, they're looking out, I think, 14 days. Let's see, 10 days. They're looking out 10 days, and they're taking it in chunks. So it's not like every day for 10 days. It's just 3 big chunks. So the 1 to 3 day outlook, which is kind of today and tomorrow and the next day, is for. Well, let me just tell you what this is. This is temperatures. I'll get my drawing tool here so I can make a mess. Over here on the left, this is average temperature for North America. I could pull up other views, and maybe I'll do that. That's average temperature, and this is temperature anomaly. So if you're looking at the temperature on the left and you're saying, I see lots of cold, I see lots of hot, but is that normal? Well, on the right, it shows you what's abnormally cold and what's abnormally hot. So here in Alaska, here, right there, we're getting some abnormal cold. Now, hence the blue and the violet and the purple colors. Down here in the U.S. South and East, we're getting some record hot over the next 3 days. And, this is record hot for March. This is not record hot for all records, for all of history, for every day of the year, through all the years. This is just for this time of year in North America. The temperatures we're going to see on the east, in the central and the east coast, are going to be hot. So that's interesting. It means it's going to be hot. And if you're expecting a certain temperature on this day in March, and you thought you know something about that, well, now you're going to find out that it's hot. It's going to be a hot day today, not a regular day, a hot day. Now, it still may be 60, 70, 80 degrees rather than 110 or 120, but for March 10th, that's today's date, it will be hot. How hot will it be? Well, let's look at the colors here. I'm going to erase this, and I'm going to say, let's just start with this area right here. I could use a smaller pen. for this area right here, this particular color, it's a dark red. If we go down here to the scale, we find that those dark red colors correspond to a temperature that's, say, I'll just split the difference, 20 degrees warmer than average. 20 degrees Fahrenheit, warmer than average. That's warm. So if it should be, and I'll just go over here and check on the actual temperature. The actual temperature in the same part of the country right over here is more in the greens and yellows. So it should be around 55, maybe 55 degrees. That means that instead it's going to be 75 degrees. I got that backwards. That whatever the temperature is going to be is 20 degrees too hot. So if it's 55, it should be, say, 35 or 45. Well, this is March. It's cold. So on average, this is going to be really hot over here on the East Coast. Now, that's not really the story, to be honest. The story is what's going to come next. We go to day 4 to day 6 outlook. And now the record heat is on the West Coast. And the East Coast, the eastern half of the country, is trending more towards normal. And then if you go to the 7 to 10 day outlook, the West Coast is raging hot. We're expecting temperatures above average of like 30 degrees above average. We're going to have a massive heat wave, and it's going to last about a week. And every time I hear the meteorologists talking about it, they use words like unprecedented, record-breaking, exceptional, dangerous. It's going to be so hot that it's going to be dangerous for people. We're going to be seeing temperatures here in the Bay Area that would be considered summertime temperatures. Hot summertime temperatures in March, not summer. Meanwhile, over on the East Coast, where it was just not too many days ago, where it was record hot, they're going to be getting record cold. And there's a word that has been adapted for this, called weather whiplash. And if you've been paying any attention to my channel and paying any attention to the weather in the U.S., assuming you're in the U.S., and that you're paying attention and you're keeping notes and you're keeping data, well, I know that's asking a lot. We've been having this situation where opposite sides of the country are at extremes, and then they flip and they take turns. We've had record cold in the West when they were having record heat in the East, and then it flips. A few days later, it flips. We go from being record cold to being record hot, and they go from being record hot to record cold, and then they have massive tornado outbreaks, and then they have 3 feet of snow, and then all their power fails because of all the ice. And that pattern, massive snowfall, massive hail storms, and massive ice storms. That has been a problem peculiar to the U.S. South, Southeast, and the Northeast. More on that in a minute. Why that is. Massive precipitation events, including ice. This is all due to global heating. How can it be due to global heating? I mean, I see the bright red temperatures on the West Coast, but you're telling me that the cold on the East Coast is due to the global heating. You get your story straight. What do you think? You think we're not paying attention? We hear what you're saying. You're saying opposites, okay? No, I'm not. I'm saying it's all due to global heating, all of it. The record heat, the record cold, the record El Nino, all of it. All of it's due to global heating. Permit me to demonstrate. I'm going to change from that to this. Now, if you've been on my channel very often, you will have seen something like this, and you may even know what this means and what this is. This is a view of the Earth from the top of the Earth, looking straight down on the North Pole. Permit me to provide some context here. I'm going to draw this down here is the lower 48 U.S. states. This over here is the UK and Ireland. This over here is Japan. Okay. Here's Spain. All right. Here's Greenland. Right. Greenland is definitely in the news these days. And the North Pole is right there in the middle. All right. That's the North Pole. This is the North Polar Vortex. This right now, the way it looks right now, this is a freak show. This is an absolute freak show. This is, I don't think I've ever seen anything like this. Not that I've been paying that much attention over the decades, okay? But certainly in the last few years that I've been watching these systems work themselves out, I don't think I've ever seen anything like this. I don't think that anybody else has either. If we go to the south of the of the planet, we see the normal behavior for a summertime system. This is the South Pole, so they're having summer going into fall, but it's still late summer, right? And they don't have much of a polar vortex. They don't, in the summer it kind of goes away. Definitely it has in this case. If we go to the 8th September of last year, okay, this is what the polar vortex in the south looks like at the end of their summer. No, at the end of their winter in the south. Okay, that's a healthy, strong winter polar vortex. In the winter, the polar vortex should look like this, and in the southern hemisphere, it does. If we go back into the northern hemisphere and look at now, this is our winter polar vortex, and that doesn't look the same at all, does it? It just doesn't. I know we're going into spring. This is late winter, but it's been looking like this the entire time. It's been looking like this for months. It has never been a complete circle with strong winds and a well-defined shape, focused, centered right on the pole. We do see that in the south. We have not this year seen this in the north. The north polar vortex has been malformed and has been largely destroyed. This phenomenon of the polar vortex breaking down as it has is caused by something called sudden stratospheric warming. Emphasis on the word warming and sudden. Okay? Sudden stratospheric warming. It breaks up the polar vortex. Why does that matter? Who cares about that? The breaking up of the polar vortex breaks up the jet stream. This should also be a circle. It's not. It's malformed, and it has all of these dips and loops and things in them. And if we go back and focus on the US, I'm going to show you what these dips and loops and whatnot do, okay? What the impact of these things are, because everything has consequences. This is not a good winter pattern. This is more like a summer pattern because things have gotten so hot. Global heating is winning, and it's real, and it has impacts. It destroyed the North Polar Vortex this winter. Who knows? Will it ever come back? I don't know. It might, but you'd have to admit that maybe it doesn't, because global heating never goes away. Never. It only gets worse from here on out. We're doing nothing to modify our behavior that is causing these changes in the Earth dynamic system. We are doing nothing to change our ways of life. We can't. I mean, I'm not saying we could, and therefore it's just a simple matter. We can't. But the fact that we can't means we aren't. And the fact that we are not changing how we do things means that none of this will ever get better. It only gets worse because we have to continue doing what we're doing. And people don't like to hear that. But that's what's happening. We can't stop. And what is it that we can't stop? We can't stop burning fossil fuels. Now, there's a war in the Middle East going on. There's a war in the oil states. The Straits of Hormuz have been closed. Everybody's worried about the price of oil. You should be more worried about the availability of crude oil and therefore the availability of fuels. And if you're wondering what happens when the fuels get cut off, read my book. Link in the description. So why is there record heat and then record cold? Let's look at the United States of America, shall we? I'm going to bring back my drawing tool. I'm going to draw some lines here. So this is... Oh, it's hard to make any sense of this. I'm going to draw this. This is the... There are so many gyres. Okay, so the north jet stream is probably doing something like this. Okay? But it could also be doing something like this. I'm not really sure which of these is the correct loop. Oh, maybe it's split, okay? And then I'm going to change colors, and I'm going to go here. And I'm going to say, okay, there's another line down here that you can probably discern. This is probably the subtropical jet stream, which comes at us from the equator. Now, what's interesting about well, it's also going up here, though, okay? What's interesting about this is that when everything below the blue line and below the red line is hot, okay? And so there's a big hot bulge out here to the west of the U.S., and there's another hot bulge right here. And then some of the rest of this stuff up here, should I have to change my color? I guess I have to change back my color. I don't mind doing that. Then everything up here, no, that's not right. I gotta start over. It's cold, okay? Everything up here is cold because it comes from the North Pole. So when these dips come down, they bring cold. And when these other things go up, they bring heat. And the waviness of this system is caused by global heating, which causes a breakdown of the polar vortex that drives this system. And the polar vortex is subject to sudden stratospheric warming, which is basically another way of saying global heating. Now, what's going to happen over the next few days is I'm going to turn something off. I've got to get rid of this tool. Okay. I'm going to turn off the motion, and I'm even going to turn off, I'm going to go with temperatures for now. No, that's ugly. We'll keep with the wind. Okay, so the United States, once again, is here. Here's the United States. Texas, Florida, the Northeast, New England states, and then the border. Okay. There's a big heat wave building out right over here. Meanwhile, there's enough of a dip here that there has been cold air dipping down, right? The cold air comes down and the heat goes up. This is not weather as such. And these patterns move from left to right, driven by the prevailing winds. So this cold air mass that's currently, going to have impacts on the U.S. is going to be pushed to the right, and this hot air mass is going to come in to replace it. And that's why you get these back and forth. First it's record cold, then it's record hot, then it's record cold, then it's record hot, and it changes every few days, right? The reason is because it's not that you're getting more or less sun. It's not weather. It's these huge air masses, some of which are coming from the equator, and therefore are hot, and some of which are coming from the North Pole, and therefore are cold, and they're moving, and they just replace each other as they move around the planet. And all of this is happening because of a breakdown of the Earth dynamic system. That's what's happening. Making things somewhat worse, and let's see if I can go to this surface. Let's see if this shows us anything. It does. Okay, no, it does actually. It does show something. So we'll stick with this. If we look at the winds in the lower U.S. states, there's this pattern here right now that's blowing in off of the Caribbean Ocean through the Gulf of Mexico and into the U.S. All these waters, including especially the Gulf of Mexico, are raging hot right now. We're having marine heat waves pretty much everywhere on the planet. I've mentioned it on this channel before, and I'll just show you again the marine heat waves we're having. The heat, the record heat that's coming for California, the record heat that's going to come for the other half of the country, all of this is coming from basically the oceans. We're having record marine heat waves. The oceans are hot. I have to switch this up a little bit, and I'm going to go with sea surface temperatures. The way you interpret this view is that the darkest red temperatures are the hottest, and then you get into the yellows and the greens, and finally up here at the top of the Earth you can see it's mostly blues, which tend to be colder. One of these blues is actually 0 degrees, and which one is it? I can determine what that is I'll just click up here. So I think this is probably 0. We'll do, okay, that's actually 2.2 degrees C. Let me get closer to the ice. Okay, that's 0. So right here, off between Alaska and Russia, it's 0 degrees, but it's right next to the ice. So that's exactly what you would expect, 0 degrees C, right next to the ice. So it's blue. But all the rest of these temperatures are well above 0, right? You expect that. You expect that really in the equatorial Earth. You can see how hot the water is at the equator. And if you visited equatorial countries, and then you've gotten into the water, then you know it's hot. The water's hot. It feels really comfortable. Southeast Asia, for example. Southeast Asia, the Philippines, these are famous places for warm water, snorkeling and skin diving and things like that. Now, let's look at the sea surface temperature anomalies. The anomaly is, well, you think it's warm, but is it warmer than normal? You think it's warm, but is it actually cooler than normal? If you lived in this place for a long time, you'd see the water and you say, wow, this water's really not as warm as it should be. The water's cold. That's what you would say. You say, the water's really unseasonably cool. It still may be hot water, but to someone who's lived there for a long time, the water may be too cool for what's average. Or they may put their toe in and say, wow, the water's really hot this week. Okay, now you and I wouldn't know that because we don't live there, but these people do know. And what they're talking about and assessing is the anomaly. They know what the average is, having lived there. And if they think it's too hot or too cold, then that's the anomaly. Well, we don't need people's opinions. We have satellites for this, and we can do data analysis. So we can actually ask a different database, are these temperatures correct, meaning normal? Correct is not the right word, right? Are these temperatures normal for the region for the time of year, or are they excessively hot, or are they excessively cold, meaning noticeably, statistically hot or cold? So we'll go to the temperature anomalies. Now here, in this view, these are not temperatures. These are departures from normal. And every place on the Earth has normal. I mean, there is such a thing as normal from the statistical record. From the annual, well, actually daily temperature measurements, we can determine what's normal for a particular square foot of the planet Earth. And every place on Earth, well, here we're looking at the water. Every place on Earth in the water has an average temperature. And we know what that is. So then we can look at the daily temperature and say, well, is this temperature remarkably hot, or is this temperature remarkably cold for what we expect it to be? Everywhere on here that's black is normal. It didn't get a color because it's normal. We can't say anything about it. It's just normal. That doesn't mean it doesn't have any temperature. It means the temperature is normal because these are sea surface temperature anomalies. And you see, there's places where it's black. There's also some places where it's blue. Let's find some remarkably blue spaces. Okay, let's go down here to Antarctica, the bottom of the Earth. You see there's these blue patches. Blue also into purple. So this is minus 3 degrees Fahrenheit. I'm going to go back to Celsius. This is a minus 1.5 degrees. So that's a temperature anomaly. 1.5 degrees below normal. Not below zero, below normal. Because these are temperature anomalies, not temperatures. Here's another one over here. This is like barely 1 degree below normal. But you see what's really happening here? Now that I've pointed out the cold spots, look at what's happening here. Most of this is actually not blue. And it's also, most of it is not black, which means normal. What is it? It's orange. It's yellow. That means above average for the time of year for this place on Earth. And, the satellites can do this for us. And all over the planet, there are hot. The oceans are hot. The oceans are heating up. The oceans actually absorb about 90% of the Earth's excess heat. And where does that excess heat come from? It comes from global heating. And that is caused by enhancements to the greenhouse effect, which we are creating by burning fossil fuels emitting CO2 into the atmosphere. And some other things we do that release methane and nitrous oxides. Plus all the water that's evaporating. These hot spots are all evaporating water. This is water. This is the sea. All these hot spots are evaporating excessive amounts of water into the atmosphere, and water is also heat trapping. Now, water doesn't have a long residency time in the atmosphere. Water resides in the atmosphere for about 9 days on average. And what happens to it after about 9 days? Sometime during 0 to 9 days, it rains out. Water rains out. Other things we put into the atmosphere, like CO2, nitrous oxides, have a long residency time. The residency time of CO2, which we are emitting every day as we drive our cars and fly our jets and drive our trucks, the trains and the manufacturing and everything else, that CO2 has a residency time on the order of thousands of years, tens of thousands of years, millions of years. The ways of removing CO2 from the atmosphere operate on geologic timescales, mountain building, mountain erosion. Those kinds of long-term, very slow processes remove CO2 from the atmosphere. A lot of it does absorb into the ocean, but the ocean's not a reliable sink, meaning the things that go in don't stay in, they can come out. And there are other sinks on the planet, like the Amazon rainforest, that can be made to release their CO2. It's quite easy to do. If you want all the CO2 that's captured in the Amazon rainforest to be released in the atmosphere, all you have to do is set the Amazon rainforest on fire. Now, I don't recommend anyone do that, but guess what? That happens every year. People set the Amazon rainforest on fire every year, and they do it for economic reasons. They can make money. It's complicated. There are lots of reasons for deforestation. Sometimes it's an accident, but not always. So here we have all this heat. Now, all of this, I'm making all this context to explain what's happening in the U.S. I'll get to El Nino later if I even feel like it. So here is the U.S. of A. in the center of the picture. And you can see Florida and you can see the Great Lakes. So this is the US of A. Can I zoom in a little bit? I'll zoom in a little bit. I'm going to grab my tool so I can make a little picture here. These temperatures right here in the Gulf of Mexico are hot. We are having globally marine heat waves. The heat content in the oceans, as you can see from this picture, is exceptional. It's a record. Everywhere you go on the ocean, whatever temperature you measure, that's hot. It may not feel hot. You put your finger in, oh, this is cold water, but it's hot. For where it is and the time of year and the everything else, it's hot. You may not know that, but the Earth system knows that, and it responds accordingly. There's a lot of energy in these systems. We're even having a marine heat wave off of California. We're having our own little marine heat wave over here, and it has affected the weather hugely. Massive changes in the California weather in the last year. Really remarkable. Really dangerous, actually. Well, this marine heat wave combined with the winds, do I have to go back to the winds? Let me just go back to the winds for a moment. These are the air winds at the surface. Okay, so you can see the Gulf of Mexico is still there. I don't have to draw that, but I am going to draw this line showing the prevailing winds. These prevailing winds are coming off of the marine heat wave in the Caribbean and the Gulf of Mexico. Therefore, these wind patterns, as they make their way up, are carrying massive amounts of moisture. This is warm air coming in off of warm water. Water that is anomalously hot. Hotter than it should be. And again, the Earth system notices. You don't notice. I don't notice. The meteorologist doesn't notice. But the Earth itself, as an engine, notices. And it uses this energy to do things. And what it's going to use this energy to do is create severe weather in the U.S. So now we've come full circle. We had some severe weather in the U.S. a few days ago. Like I said, 8 people were killed in tornadoes. They weren't expecting those tornadoes. Why were they not expecting those tornadoes? Because it's March, and the tornadoes really spin up in May. And so it's March. If they're warning us about tornado outbreaks and severe tornadoes and life-threatening tornadoes, well, you can ignore that because it's March. And so they did. And so they died. Now, the fact that these people died, the fact that these people ignored the warnings, the fact that these things happen, that's data. And what is that data telling us? The data is telling us they didn't believe it. The reason they didn't believe it is past patterns taught them to not expect this. But the Earth system is changing. We're having marine heat waves. Those never go away. They never go away. There's nowhere for them to go. The Earth is hotter. The heat goes into the water. And the Earth keeps getting hotter. And the thing that makes the Earth hotter is the greenhouse effect. And the problem with that is that the greenhouse effect is being augmented every single day. Every single day, every single year, we launch something like, every year we launch something like I think it's like 39 billion with a B tons of carbon dioxide into the atmosphere annually. Almost 40 billion tons. 40 billion tons of CO2. And there's nowhere for it to go. It just goes in the atmosphere. And from there, it doesn't go to space, and it doesn't go to Mars, and it doesn't go into a canyon or a cavern. It's in the atmosphere. And it doesn't rain out. It doesn't leave. It just stays there. And as it increases every year, it increases global heating. And the planet gets hotter. And as the planet gets hotter, the oceans get hotter. And as the oceans get hotter, that drives weather patterns. Forever. This never changes. Except that it gets worse. That's how it is. That's how it'll stay. Because it can't change. Am I making myself clear? It is the way it is. We did this. We can't stop doing this. Now we're having this big dust up in the Middle East, and maybe we'll blow up a bunch of oil wells, we'll blow up a bunch of tankers, we'll blow up a bunch of refineries, we'll put a halt to the movement of oil. No one gets oil, the price goes up, no one can afford gas and diesel, and they stop driving, and they stop flying, and they stop cargo ships, and they stop all this other stuff. So maybe we do stop burning fossil fuels. But it's not voluntarily, is it? It's because of a collapse of the global economy. We somewhat curtailed our consumption of fossil fuels at the peak of the COVID-19 pandemic. Because what? People weren't driving. They weren't flying. They weren't partying. They weren't vacationing. They weren't doing anything. Of course, they hated it. And they blamed the governments, and they overthrew the governments, and they stormed the Capitol, and they did all the things. Right? They didn't like it. But it did reduce our carbon dioxide emissions, and it did reduce our fossil fuel consumption. So that's a thing. It also blew up the global economy. The global economy is still recovering from the COVID-19 pandemic, the peak of which was about, 2020 or 2021 or something like that. And still hasn't recovered. People still are bitching and moaning about the price of things and all the jobs that were lost and all the terrible things the governments did to us with the shutdowns and the lockdowns and everything else. People still complain bitterly that this was all terrible and shouldn't have happened and blah, blah, blah. Well, it did happen. And, it curtailed some of our economic activity, and the global economy almost imploded. It almost just went away because of the pandemic. And people bitched about it, and they complained. Don't ever do that again. Don't ever tell us what to do. Don't give us vaccines. Don't make us stay home. Don't do anything. Okay, well, now we're not doing that, but now we're having a war in the Middle East. Could that do the same thing? Could that shut down the availability of oil? Shut down refineries, shut down the transportation of goods and the driving and the flying and the vacationing and the buying and the selling and the everything else? Well, that's the concern. But if it does, it won't matter. Frankly, to this picture, it won't matter. Because this picture, going back to my ocean picture and my sea surface temperature anomaly, this picture takes hundreds of years to change. And after you stop increasing the Earth's temperature. And you don't stop increasing the Earth's temperature until you stop enhancing the greenhouse effect. And you don't stop enhancing the greenhouse effect until you stop carbon emissions. And you don't stop carbon emissions until you stop burning fossil fuels. That's it. So this can't change, can it? Because we can't stop burning fossil fuels. This only gets worse. And so what's happening? What's happening is, again, within a few days, the same winds that were blowing in, they're going to blow in all this hot, moist air into the U.S. Central states. And then there's going to be a answering a blob of cold air coming down because the northern jet stream is broken, and all this cold air is going to come down, and this hot moist air is going to go up, and they collide right in a band right about here. That's where they collide, and they did that a few days ago, and they're going to do that again tomorrow, and the day after, and the day after that, and next week, and next month. And when does it stop? Never. It can't stop. It never stops. Meanwhile, over here in California, we're going to be getting a completely different effect. We're going to be getting our generally prevailing winds that come in off of this side. It's going to bring a big ridge from the subtropical jet stream, and this is all hot air. And they'll tell you, oh, well, this is a high pressure gyre, and it's going to settle right over California. It's going to park there, and it's going to stay there. It's going to elevate our temperatures by about 30 degrees over normal. 30 degrees. Now, that's 30 degrees in the air, not the water. But still, 30 degrees is going to leave a mark. And we have a huge snowpack in California. And now this hot air is going to arrive and sit over the snowpack for 10 days, a week to 10 days. Record heat, just being hot. And it's going to melt the snow. So you can start, and I said this a couple of weeks ago. I've seen this in my life. In my lifetime, I've seen this. You end the winter with a record snowpack. You're really happy with the snowpack because that becomes the water that we drink in summer and use for irrigation in summer and fill our reservoirs in the summer. The snow melts gradually, and it fills the reservoirs, and it fills the creeks and the streams, and it fills the irrigation channels, and it fills the fields, and we drink it. All the uses we have for water comes from the ice in the Sierras. Except what's going to happen now is it's all going to melt. It's all going to melt. It's all going to come down at once. It won't be there in the summer. In the summer, it'll all be gone because it melted during March because we had a huge heat wave and it melted all the snow. So that's what's going to happen now. We're going to have flooding. We're going to have wasted water. It's going to run out to sea. And people are going to say, oh, no, what are you doing letting all this water run out to sea? We're going to need it this summer. Or the reservoirs are full. The reservoirs are full. There's nothing we can do about the melting snow. It's not supposed to do that. But it is doing that because of what? What's the word we're looking for? Oh, yes, that's right. The global heating. You can't have snow in the Sierra Mountains in a regime of global heating. You can't have snow. You can't have snow anywhere. They're losing snow in the European Alps. They're losing snow and ice in the Himalayan mountains. It just is melting everywhere. It's melting everywhere. Because of global heating. Global. It's right there on the word. Global. Global. Ice is melting everywhere on the planet. And because of that, we're getting weird weather. Whiplash weather. Record cold, record hot, record cold, record hot. Fire and ice and fire and ice. But it's really all fire. It's fire. Global heating. It's fire and fire and fire and fire. And when the fire breaks down the Earth dynamic system, yes, you can get cold. But right after that, you get fire, and then more fire, and more fire after that, and then you get some cold because things are broken, and then you get fire again, and that's how this proceeds. That's where this goes, people. That's where this is headed. That's all it can do. That's it. That's all we've got. That's all we've got now. Fire and ice and fire and ice and fire and fire and fire. That's it. That's your future. That's your present. Back to this, the 1 to 3 day outlook looks like this, and then we have a transition, and then it looks like this. Fire and ice and fire and ice. Oh, by the way, the ice in question, of course, is coming from the north. Here's a big blob of cold air, and this is able to slip south. It mostly happens in the eastern half of the continent of North America. I don't know why. Just the way it works. It's atmospheric waves. Enough said. So it descends mostly into the eastern half of the country. you can have these cold waves. This is a big cold thing up here. You can have these cold waves only so long as there is cold. But that doesn't always work. And I can show you a little something here. We can go to the Arctic. This is now the Arctic, the top of the world. Okay, the North Pole is right in the center. The North Pole is right here. The North Pole is right here. Okay. Again, the picture on the left is the actual temperature. The picture on the right is the anomaly. Okay, is it colder than normal, or is it hotter than normal, or is it normal? And so we don't really care about the picture on the left. Yes, we know it's cold in the north. That's what it's telling you. It's cold in the north. Oh my goodness, how cold could it be? Oh, it could be, according to this, it could be like minus 30 degrees. Centigrade at the North Pole. Well, we know that. We know it's cold up there. But what we don't know is that normal cold, or is it not as cold as it should be? Well, guess what? Well, what's the theme here of this video? What's the theme of this channel? What is the theme of all the trends in the Earth dynamic system? What's going on here? It's not as cold as it should be. Here's a big heat mass right over Russia. Russia is supposed to be the coldest place on Earth. It ain't. Well, it is, but it's not as cold as it should be. They're suffering a heat wave relative to where they are. Not relative to Miami, Florida. Not relative to Madrid, Spain. Relative to where they are, they're having a heat wave. Over here in Russia, they're having a relative heat wave. And I want to show you something else. Right here. You know what this is? This is the island of Greenland. Greenland is covered with ice. They're having abnormally warm temperatures. Now, it's not warm enough to unfreeze the ice, because over here in this other picture, you'll see that over Greenland, over here on the left, our temperatures are more like 25 or 30 degrees below 0 centigrade, okay, Celsius. Still cold enough to have ice, but it's anomalously warm for the time of year for that place. We're having global heating. And when it's record cold, you can see over here in the left-hand corner, right? This is the U.S. When the record cold is dropping down into the U.S. from Canada in this case, there's record heat being transported into other parts of the world in the north, and that's what happens with these systems. For the cold air to descend from the North Pole, warm air has to rise to replace it. Now, eventually what happens is that there is no cold air. The ice melts, the ocean heats, because they're having marine heat waves, so that continues. The ocean gets hot, not hot like you would think, but just hot enough not to melt, not to have ice. All it has to be is too hot to have ice, too hot to freeze water. And so if it ever gets to being so hot that it can't freeze water, you don't have ice. That's it, the physics. Eventually, you can't have cold air in the north. Not as cold as it should be. So eventually, all of this weather whiplash ends. It ends because the cold air ends because of global heating. That's what's happening. It's called global heating for a reason. The globe, the planet, the water, the atmosphere, the lithosphere, the hydrosphere, the cryosphere, all of it is getting warmer all the time. Global heating. And if I go back to this, and I make this a bit smaller, and I pull this up, and I come over here, and I go back to my atmosphere, and I go up into the jet stream, which is the best view. This may be the best view. Okay. All these loop-de-doops in the jet stream, all this stuff that's going on, all this malformation, okay? Unknown to most people, what's happening here is that the subtropical jet stream is moving north. All the time it's moving north. This line, even though it's looping and doing other things, this line is moving north. Okay? And this line up here, which is the polar jet stream, is basically just falling apart. And eventually what happens, because this is how it has to be, it has to be this way, is that the northern polar jet stream, which is holding all the cold back, vanishes. The cold escapes. But more important than that, the heat moves north. The cold vanishes. It can't be cold anymore. The subtropical jet stream becomes the jet stream. And all the heat that is present down here at the equator, all the heat that's accumulating down here at the middle of the Earth, it makes its way north. Because the ultimate destination of all this is that the Earth becomes pretty much one temperature from pole to pole. But the way that happens is that the warm air at the equator makes its way north and it makes its way south. Both of these events take place. And eventually there's no cold air anywhere on the planet. Well, relatively speaking, it might be colder in the north in the winter. Relatively speaking, it might be colder in the south during the southern winter. But as a rule, the Earth becomes one temperature from pole to pole. This happens first in the north, because in the north there's less land. The north is not land. The North Pole is surrounded by an ocean, the North Polar Sea. This is all water. And what's interesting about having water at the North Pole is that means that the ice can melt. The gray here is ice. The ice can melt and be replaced by warm water. And you kind of see that happening over here on the right. There is already ice melt going on here. This is normal. This is an annual thing. There's ice melt going on here because there's warm water coming in from here. Warmish. I mean, it's not. You wouldn't call it warm, but in this discussion of ice and whether we can have ice or not, this is warm water because it melts ice. That's it. That's all you have to know. It's warm water, warm enough to melt ice, and that's it. End of discussion. And without ice, you can't have cold. Without cold, you can't have a polar vortex. And without the polar vortex, you can't have a north polar jet stream. And without the north polar jet stream, you can't hold back the cold. And without holding back the cold disappears. And when the cold disappears, it's replaced with warm air from the subtropics. And you're done. You're done. We are now in the process funnel. We are now in the pattern of change that is going to destroy all the ice in the north. The process has begun. Do I have to? God damn it. All right, I'll do it. I'll do it. Trying to be complete here. Let's go look at the ice, shall we? Let's do some science with the ice. Oh, we do love our data. All right, this is the Arctic sea ice extent. And right now we are over here, we are March. No, it's 9th. I guess the last data is March 9th, which was what? Yesterday, so we're pretty much current. All right, this point right here, 14.2 million square kilometers. That point is below the average. The average is this line here, with some error bars. These gray lines on either side of it. But this line here, that's the average. Okay, we are down here. We are way below average. We are significantly below average because we're outside the error bars. We are significantly below average. Other times we were below average last year. And the year before that, well, that was almost average. The year before that, 2024. 2023, I'll have to get rid of 2024. 2023 was also below average. So the last several years, of the last 4 years, we don't have a full 2026, but let's just say, let's bring in 2022. 2022 is almost within the error bars, not quite. Okay, so of the last 5 years, 4 have been below average, strongly below average. In 2024, the only outlier was only barely able to eke out an average. So in the last 5 years, 4 of the last 5 were below average ice extent. The ice is melting. There's not as much of it as there used to be. If you want to see what ice is supposed to look, what ice used to be, you have to bring in this line. This is 1983. Now that line is above average because really, I mean, you can even say that line used to be average. All these years used to be average. But what's happening is that the average is dropping because the extreme pressure is to decrease the ice. And so every year we decrease the ice. And every year that happens, the average is decreasing. That's how averages work. So there was a time when all the ice measurements were up here in the top of this so-called average. And now, in more recent years, all the ice measurements are down here in the bottom. Because that's what's happening. That's what's happening. We're losing the ice every year. On average, there's less of it. And this continues. And I don't know, at some point there's going to be a year where the average is down here. And then some years after that, the average will be down here. And at some point in the future, the average will do this. It'll go to zero. No ice. And it continues. No ice, no ice, no ice, no ice. And then maybe it starts to increase again when the cold season comes in the north. And then sometime after that, there's no ice. It never recovers. Maybe it has a little bit of a blip. Maybe in the very dead of winter, the worst part of winter, you get a little bit of ice, and then it goes to zero. And and that's how the ice is. And why is that? Because the northern part of the planet is an ocean. The North Pole is an ocean. And once this hot water intrudes over and over and over and over again, then pretty soon this entire North Polar Sea contains hot water. Hot for that region. Doesn't have to be hot enough to snorkel in. It can still be what you would call freezing. But to make ice, it has to be actually freezing, not what you would call freezing. Not what you wouldn't want to swim in or wade in. It has to be 0 degrees C to be freezing. Words have meaning here. So even though the temperature of the water in the north may end up being 2 degrees C, which is too hot to be too cold for you to be in as a mammal, 2 degrees C melts ice. So there you go. You can't have ice at the North Pole. And then what happens? Well, I think you don't have a North Polar vortex. And because you don't have a North Polar vortex, that degrades the northern jet stream. And it's the northern jet stream that keeps the hot air from going all the way to the north. So without the jet stream, or with a pussy jet stream that can't hold back the tropical heat, the tropical heat just goes north. It just migrates north. And it melts all the ice again. So you have hot water coming in, and you have hot air coming in, and pretty soon all the ice is melted, and then Greenland starts to melt. Because Greenland is land-based ice. So the temperature in the water doesn't really automatically, immediately affect the ice on Greenland, because Greenland is land-based ice. But when the hot air comes in, then it certainly does. And if the hot air comes in from the subtropics, bringing tropical storms, then the rain melts the ice. Rain is a natural enemy of ice. And when you start getting rain on Greenland, because subtropics, well, then the ice disappears on Greenland, like immediately. Immediately, meaning generationally. 20 years, 30 years, something. Now, people say, oh, that's nuts, you can't do that. But we haven't seen these effects yet. We'll find out, won't we? If it starts raining on Greenland much of the year, much of the summer, much of the whenever, much of the winter, if it doesn't snow anymore and it starts to rain, or snows very seldom and it starts to rain more often, then how long does it take to melt enough ice on Greenland to make a difference to sea level rise? You don't have to melt all of it. You just have to melt enough that it raises the sea level, or stops the AMOC, or does something else. So again, the key to all of this is not that, oh, we're having weather whiplash, it's all exciting, it's all strange, it's all weird. The key to all of this all of this discussion of ocean heat waves and marine heat waves and breakdown of the AMOC and breakdown of the ice in the north and all these weather weirdness and the weather whiplashing and the record cold followed by record heat followed by record cold, all of it being symptomatic of a breakdown of the jet stream. All these things are symptoms of something that is important and that is not weather, and that your meteorologist will not discuss with you because your meteorologist doesn't understand it. And that's a breakdown of the Earth dynamic system. The Earth system is on the move. It's going somewhere. It's taking us with it. We live here. We live inside of all of this. Everything I've described is happening around us. We are inside of it. And there are times when we appreciate that rather abruptly, when a huge tornado outbreak happens in the middle of March, or early March, that nobody was expecting. Then we feel it. When huge hurricanes come ashore and they're category 4, category 5, and they undergo bombogenesis, or in the case of some of the recent ones, double bombogenesis, then we feel it. We recognize that the system is changing. Something happened. People will be in denial. Well, we can have tornadoes in March. Can you have 2 double outbreaks of lethal tornadoes in March where you live? In Michigan? In Missouri? Well, we've had tornadoes. Yeah, but like this? Because it's killing people. And they're not listening to the emergency messages. And they don't believe it. You see, they don't believe it. That's telling me. I don't have to live there to know something about these people. I don't even have to live there to know that these tornadoes are abnormal. Because the people there tell me that they didn't believe it. That's data. They didn't believe it. And when the outbreaks start again this afternoon and tomorrow, it'll kill even more of them. Because even though this just happened a few days ago, and now it's happening again, they don't believe it. They still don't believe it. And it can't happen to me. It happens always to someone else. I know what I'm talking about. I know what I'm doing. I don't have to worry about this. We've never had a tornado in our neighborhood, our community, our county, our city. This never happens to us. And then, here you go. You just had a tornado outbreak. It destroyed your downtown, turned your car upside down, whatever else, tore the roof off your house. So now you're thinking, wow, that was unexpected. Well, I've never seen that before. And the newsman comes up and says, well, did you get the emergency alert that you had a tornado? Yeah, but I ignored it because I didn't believe it. Whoa. Well, I thought it's a hoax. And someone was telling me that none of this is real. And it's all a hoax. And it's all fear-mongering. And it's all trying to make money off of fear. And I didn't believe it. And I didn't want to believe it. Now I don't have a roof on my house. Well, of course, you're not going to have a roof on your house, whether you believe it or not, right? The tornado doesn't care who believes and who doesn't. It's not skipping this house because this guy accepts climate change and tearing the roof off of this other house next door because this guy's a denier. That's not what happens. Everybody loses a roof off their house. And some people will say, yeah, well, global heating is real. And the other guy will say, what are you talking about global heating? It's a hoax. Yeah, well, let me show you some data. Let me explain to you why this is happening to us and why this isn't going away and why it only gets worse and why we are now in the crosshairs of climate change. Now, people don't have those kind of conversations. People will never have those conversations. That's my job, is to have that conversation. I don't know. What's my job? Do I have a job? Here I am at work. I'm at work, and frankly, I got other things to do. We'll see. Don't forget to like and subscribe. It helps the algorithm push this out to more people. I would appreciate that. And people need to know. People need to know what's coming for them. People need to know that they are in trouble. And my earlier prediction stands. I was lamenting a couple months ago that we are jumping out of the frying pan into the fire. The heat is coming. The heat is coming. Wait till the El Nino kicks in. Merciful heavens. We are in such trouble. And the heat waves are just going to get worse. And the rain and the tornadoes and everything else is just going to get worse. Because it's going to get worse. Because it can't do anything else. You see, it can't do anything else except get worse. That's all it can do. Not because I say so, but because of physics. Physics. It's all physics now. It's all math. It's math and physics and earth dynamic system physics, and we barely understand it, but we do know it's getting worse. That part we do know. So it gets worse. When does it stop getting worse? Never. You've got worse in the pipeline for, I'd say, 30 years, maybe 50. Yeah, every year. Weirder. More whiplashy, worse. Well, until we run out of cold air. Then I guess if we run out of cold air, then we'll have a different set of problems. I guess it'll be nothing but heat waves at that point. But at least you won't have weather whiplash. Record cold, record hot, fire, ice. It'll just all be fire. Fire. We'll all yearn for the days when once in a while it came record cold. And we used to have snow and we used to have ice storms, knock down all the electrical wires and all these terrible things. The cars get stuck in the ice and people are like, wow, ice, snow? Really? Tell me more, Grandpa. How high did the snow get? Oh, it was this high and you would have just been buried in it. Wow, tell me more, Grandpa. What's a snowman again? Tell me about snowmen. Like and subscribe. Even if you don't like it. Like and subscribe. And share. Send this to someone who lives in the upper Midwest. Send this to someone who lives in Michigan. If you got family out there and friends, they need to know. They need to know what's happening to them. Because they're not going to get it from the meteorologist, as well-intentioned as they are. They're too afraid to bring it up. I'm not afraid to bring it up because I'm a savage. Here I am, being savage. Keep an eye on this, okay? Keep an eye on this. It's coming for you. I don't care where you are. You're going to get yours. You are going to get yours. We're all going to get something. We're all going to get a taste. My recommendation is don't die.